The remainder and factor theorem. What is the remainder theorem? The remainder theorem states that if you divide a polynomial f of x by a factor of x minus k, the remainder will be equal to f of k. Why should we use it? The remainder theorem can serve as a simpler and more efficient way to evaluate a polynomial. How would we use it? We use the remainder theorem to evaluate a polynomial f of x by utilizing synthetic or long division to divide the polynomial f of x, which is the dividend, by the polynomial d of x, which is the divisor, to find the remainder. What is the factor theorem? The factor theorem states that a polynomial f of x has a factor f of k if and only if f of k equals 0. Why do we use the factor theorem? The factor theorem is used to show whether x minus k is a factor of a polynomial f of x. How do we apply it? You apply the factor theorem by evaluating the polynomial at x equals k. If the result is 0, x minus k is a factor of the given polynomial. Students must be able to do synthetic division. Here is a simple example of synthetic division. The first step is to identify the k value. In this case, the k value is -1. The next step is to place the k value on the left and the coefficients of the polynomial above, as shown in the video. The next step in synthetic division is to drop the 1 down. Next, multiply by the k value, which is -1, to find the next number, which is -1. Then, add the two numbers, 2 and -1, to find the value on the bottom. Repeat this process however many times needed until you get to a final number. In this case, we end with a remainder of 0, and by the factor theorem, we can conclude that our answer is x plus 1.
Here's a simple example of applying the remainder theorem to evaluate the polynomial function.
Use the remainder theorem to evaluate the following function. F of x equals to 5x cubed plus 6x plus 8 when x equals to 2.
As you can see here, by using synthetic division, we can come up with a remainder of 60. By the remainder theorem, we can conclude that f of 2 is equal to 60.
You can see here that the same result is achieved when substituting 2 into the given function and when applying the remainder theorem. First, we divide the polynomial by the factors x minus 2 and x plus 3 with synthetic division. So here we divide the polynomial by 2 first, and we are left with a remainder of 0. We can conclude on the basis of the factor theorem that x minus 2 is a factor of the polynomial. After dividing the original polynomial by x minus 2, we are left with 2x cubed plus 11x squared plus 18x plus 9. We repeat the same process with x plus 3, and we are then left with 2x squared plus 5x plus 3. Once the degree of the polynomial is 2, we can simply factor the polynomial. So 2x squared plus 5x plus 3 completely factored is 2x plus 3, x plus 1. Therefore, the remaining factors are 2x plus 3 and x plus 1.
One of the most common errors made is that in the remainder theorem, the polynomial f of x is divided by x minus k. Therefore, x plus 3 should be changed to x minus -3, and as a result, the k value is -3 as opposed to +3. As you can see here, making this mistake will result in a completely different answer. As you can see here in the polynomial 3x to the 4th power plus 2x squared plus 3x plus 5, we must substitute 0x cubed as a placeholder, as shown on the right. Forgetting to input 0x cubed will result in a completely different answer.